All right, geometry. So we just finished chapter 10 and we are going to start chapter 11 today. We're actually only going to hit about 3 sections in chapter 11. So today we're going to do 11.1, which is finding angle measures and polygons. So this year we've talked a lot about polygons. We spent several chapters talking about triangles. We spent a couple of chapters talking about quadrilaterals, and in this chapter we're going to talk about polygons of many different sizes and number of sides. The first theorem that we're talking about is called the polygon interior angle theorem, and this theorem is going to allow us to be able to find out the sum of the measures of interior angles. Now you already know for a triangle that those 3 angles are always going to add up to 180. We also know for a quadrilateral that those interior angles are going to add up to 360. But what if you have a 5-sided figure, or a 10-sided figure, or a 327-sided figure? How do you find the sum of the measures of the angles? And that's where this theorem comes in. So we have a formula, and it is S equals 180 times, and then in parentheses, n minus 2. So the S represents the sum of the measures of the interior angles, and the n represents the number of sides that our polygon would have. So let's see how we can apply this with example number 1. In example 1, it says find the measure of oh boy, I can't read. Sorry about that. Find the sum of the measures of the angles of a nonagon. We've talked about that word nonagon a couple of times this year, and that's a word that you should know by now. We should know that that means that there are 9 sides in this shape. So we're going to use this formula that we just learned about, and our goal is to solve for S. We want to know the sum of the measures of the interior angles if our shape has 9 sides. So we're going to do the order of operations, and first thing is we're going to do subtraction because it's inside of the parentheses. So 9 minus 2 is 7, and then we're going to multiply 7 times 180, and we get 1,260. And I'm going to put a degree symbol there because remember this represents angle measures. So if we had a figure that had 9 sides, then all 9 of the angles would have to add up to 1,260. Now real quick, I just want to kind of off to the side explain to you why this formula is what it is. So we've already learned several chapters ago that if you have a triangle, the sum of your measures is 180 degrees. We also learned about quadrilaterals, and at the time when we learned about quadrilaterals, I drew on the board a 4-sided figure, which I cut into 2 triangles, and we know that each triangle has a measurement of 180 degrees, and so that's a measure, a total measure of 360 degrees. Well, what happens if I go to a 5-sided figure, and if I were to start at a vertex and then create triangles? So let's say I do that one, and then I draw a line right there. How many triangles do I have? I have 3. So I have 180 from each of those triangles, which gives us a total of 540 degrees. So the reason that this formula came about, S stands again for the sum of the measures of the interior angles, n minus 2. This was a 3-sided figure, but it was 1 triangle. This was a 4-sided figure that created 2 triangles. This is a 5-sided figure that created 3 triangles. So you see a pattern here that every time the number of sides, when you subtract 2 away from it, that tells you how many triangles you can form, and then you're multiplying that number of triangles times 180 because each triangle is 180 degrees. So I just wanted to give you the background of why the formula, or how the formula came about and why it works. Let's take a look at example number 2. It says find the value of x in the diagram below. So let's see, how many sides do we have? 1, 2, 3, 4, 5, 6. So this is a hexagon. Hopefully you remember that word. So normally we would take all of these angle measures and we would want to add them together. So I've got 88, 136, actually we have 136 twice. We have 105, we have 142, and then we have the missing angle x. And at this point, we want to add those together and set it equal to the total. But that's where this formula comes in because we don't know the total yet. We do know that we have a 6-sided figure. So I'm going to plug in the 6 in place of the n. So 6 minus 2 turns into a 4. And 4 times 180 is 720. And that is useful for us because now we know what all of this should add up to. So the measure of those interior angles should add up to 720 degrees. So the next thing that I would do is I would want to combine like terms. So I want to add the 88, the 136, the 136, the 105, and the 142. And when we add all of those numbers together, we get 607. And that 607 is still added to the x and set equal to 720. So now comes the easy part. We're going to move the 607 over to the other side using subtraction. And we're going to find out that the missing angle is 113 degrees. And for this problem, that's all that they asked us to solve for. And so once we find x, we are done. Okay. Example 3 says find each, typo, that doesn't make much sense, does it? Let's get rid of that word, the. Okay, find each measure, or maybe it should just say find the measure of each interior angle, whatever, just get rid of one of those words, sorry. Find the measure of each interior angle of a regular octagon. So first let's talk about that word regular. We have learned that word previously. We know that that means that all sides and angles are congruent. Remember, that means that your shape is equilateral and equiangular. Equilateral means all of our sides are equal. Equiangular means all of our angles are equal. So what shape do we have? Well, this is an octagon. Looks like a stop sign, right? It's an octagon. It has 8 sides. So I can easily find out how many degrees are in an octagon by using the formula that we have learned today. So we're going to end up having 180 times 6, and 180 times 6 is 1080. So we know that all of those angles are going to add up to equal 1080. Now, what do we know about all of the angles? Well, that's what this keyword right here tells us. It tells us that all of those angles are congruent. I'm just drawing an arc there so we can see that they're all congruent. And how many of them do we have? Well, we have 8, because if you have 8 sides, you have 8 angles. So the question is not how many degrees are in the octagon, but what's the measure of each angle. So we're going to take the total number of degrees, we're going to divide by how many angles we have, and whatever we get out is going to be the measure of each angle. So 1080 divided by 8 is going to give us 135. So each angle is 135 degrees if it is a regular octagon. All right, example 4 says the sum of the measures of the interior angles of a convex polygon is 2,340. So basically what they've given us is the value for S. Remember, the S stands for the sum of the measures of the interior angles. So that's what they gave us. So this problem is asking us to classify the polygon by the number of sides. In other words, we need to find N, right? So we're going to go back to our formula that I'm writing down. And this time We don't know the N, but we do know the S. So I'm going to plug that number in place of the S. Couple ways you could go about solving this. If we want, we could go ahead and do the distributive property. So we're going to distribute the 180. So we get 180n minus 360. We need to move that 360 over. So I'm going to add it on over. And now I have 2700 equals 180n. And then we're going to divide each side by 180. I can go ahead and get rid of 1 0 in both the top and the bottom. And 18 would go into 270, a total of 15 times. All right, so the question says classify the polygon by the number of sides. So we know that it has 15 sides. Now remember, we did learn some vocabulary. If it's a three-sided figure, we call it a triangle, not a trigon, right, Clark? If it's a four-sided figure, it's a quadrilateral. Five-sided figures are pentagons. Six-sided figures are hexagons. Seven-sided figures, we call those heptagons, or sometimes you might hear them called septagons. Eight-sided figures are octagons. Nine-sided figures are nonagons. 10-sided figures are decagons. Remember, we didn't have a name for 11, at least not one that I'm aware of. 12-sided figure is dodecagon. But if you remember when we talked about polygons in previous chapters, we said, okay, once it gets bigger than 12, we just call it an n-gon, where the n represents the number of sides. We just found out that this has 15 sides, so we're going to call this a 15-gon. So we have classified the polygon based on the number of sides. All right, so we've talked about interior angles. Now let's talk about exterior angles. And this is the polygon exterior angle theorem. And it says if a polygon is convex, then the sum of the measures of the exterior angles, one being at each vertex, is 360. This is true regardless of what shape you have. If you have a triangle, if you have a quadrilateral, if you have a hexagon, if you have an octagon, if you have a dodecagon, does not matter what shape it is, but if you add the exterior angles up around that shape, it will always add up to 360 degrees every single time. So in other words, let me draw a shape here real quick just to give you a visual. All right, so at each vertex, I've got, let's say, here's an angle right here. I'm going to keep this side going. Here's an exterior angle. And if I keep that side going, that's an exterior angle. Those three exterior angles right there that I just shaded would add up to 360 degrees. Now, if I had a different shape, let's say this time I do a pentagon. If I do the same thing, so if I keep this side going, so I have this angle, and I keep this side going, so I have this angle, keep that side going, so I have an exterior angle. I'm going to do that over here, and do that over here. Again, I have one exterior angle at each vertex. If I were to add those 5 angles together, I would get 360 degrees. So it does not matter what shape you have, your exterior angles will add up to 360. So example number 5 says find the measure of an exterior angle of a regular no, I can't read tonight. What? No. Jeez. Y'all, I am losing my mind. Let me try again. Find the measure of each interior angle and exterior angle of a regular octagon. There we go. Okay, so looking at the picture, X represents the interior angle, Y represents the exterior angle. Okay, let's start with the exterior angle because I kind of want to use that theorem right here. We know that all of the exterior angles are going to add up to 360. If this is an octagon, how many exterior angles will I have? Well, it's going to be the same number of sides that you have. So an octagon has 8 sides, so I have 8 exterior angles. So I know all of them add up to 360, but I'm going to take that 360 and divide it by 8. The reason I'm doing that, and this is important, is because it used the word regular. That means all of the interior angles are going to be equal. It means all of the exterior angles are going to be equal. So again, the 360 came from all of the exterior angles, and we are dividing by 8 angles, and the number we get is going to tell us how much one angle is. So 360 divided by 8 is 45 degrees, and that represents the exterior angle, otherwise known as Y in this picture. All right, to find the interior angle, we have two options. We could go back to this formula, S equals 180 onto N minus 2. We could find out how many degrees there are inside of the shape, and then we could take that number, whatever we get, and divide it by 8, because that would tell us how much one single angle is instead of all 8 of them together. But if you already know the answer for your exterior angle and looking at the picture, what is the relationship between the interior angle and the exterior angle? Those two angles together make a linear pair. Remember, we learned about linear pairs in chapter 1. They have to be supplementary. That means they add to 180. So if I already know my exterior angle is 45, and we just identified the fact that these make a linear pair, then I'm going to plug the 45 in for the Y, and now I need to subtract it over to the other side, and that is going to leave us with an interior angle value of 135 degrees. So if you can find one of the angles, whether interior or exterior, you can find the other one simply by knowing that they make a linear pair. That would make the problem a little bit easier for you. You can still do it this other way, but it would require more work. Okay, example 6. The measure of an exterior angle of a regular polygon is 20. Find the number of sides in the polygon. Okay, so exterior angles. Remember, we said that all of them add up to the magical number of 360. If I know that one of them is 20, how can I use the 20 degrees to find out how many sides there are? Well, let's see. So the 360 is all of the exterior angles. If I divide that by 20, which is representative of one exterior angle, then whatever number I get is going to tell me how many angles, also known as how many sides there are. So 360 divided by 20 is 18, and that means that there are 18 angles as well as 18 sides. So we have found the number of sides in the polygon. All right, example 7 says the measure of an interior angle of a regular polygon is 144. Find the number of sides in the polygon. Well, this particular example is pretty similar to this one with one difference. In this example, we knew the measure of an exterior angle. In this example, we know the measure of an interior angle. But let's review for just a minute, because what did we say is the relationship between the exterior angle and the interior angle? Remember, we said they make a linear pair. That means they're going to be supplementary. So together, they're going to add to be 180. Well, what this problem tells us is that the interior angle is 144. Can we use that information to find the exterior angle? Absolutely, because now we can take the 144, subtract it over to the other side, and that gives us an exterior angle measure of 36 degrees. Now, why would I want you to find that? Well, look how easy this problem was. We knew that all of the exterior angles add up to 360. Up here, we divided by how much one of the angles was. Well, in this problem, one of the angles is 36. And whatever answer we get when we do that is going to tell us how many angles, how many sides are in the shape. So 360 divided by 36 is 10. So there are 10 sides to this. Now, if it said classify this polygon, we would be able to say this is a decagon. But here it just says find the number of sides. So that's all we need to know, is that there are 10 sides in that shape. All right, almost done, y'all. Example 8 says there are 15 sides in a regular polygon. Find the measure of each exterior angle. Okay, so again, if there are 15 sides, that means there are 15 interior angles. There are also 15 exterior angles. What did we learn today about all of the exterior angles? They all add up to 360. So if I take 360 and divide by how many sides, how many angles there would be, that will tell me how much one single angle would be. So we've got 360 divided by 15, and it is going to go into that 24 times. So each exterior angle is 24 degrees. Now, if you don't think to do it this way, I do want to show you that you could do it another way. We could go back to this formula of S equals 180 onto N, which is 15, minus 2. 15 minus 2 is 13, and 13 times 180 is 2,340. Now remember what the S means. The S means how many degrees for all of the interior angles. Well, how many interior angles are there? There are 15. So if I take this number and divide by 15, that will give me the measurement of one angle. So here my angle would be 156. Again, what did we learn today about the interior angle and the exterior angle? Those two make a linear pair, which means they're supplementary and they have to add up to 180. So I'm going to replace the interior angle with the 156. I would need to subtract that over to the other side. And again, I'm going to get the same answer of 24 degrees. Personally, I would rather do it that way. You see how much less work that was? If you choose to do it that way though, that's fine too. So you can pick which way you want to get the answer. You just need to make sure that you're coming up with the correct answer. Example 9 says there are 36 sides in a regular polygon. Find the measure of each interior angle. Okay, I'm going to go with the easy way, y'all. Now we can go with the harder way, but I like the fast way. What do I know about the exterior angles? They add up to 360. How many exterior angles will there be? 36, because there are 36 sides. So that means that one exterior angle has a measurement of 10 degrees, which is not what the question is asking. The question is asking for the interior angle, but that takes me back to this right here. The exterior angle and the interior angle make a linear pair, so they have to add up to 180 degrees. So if I've already used up 10 degrees, how many degrees are left over? 170. Again, you could do this the long way, which would be doing this over here, or you can do it the fast way. It is completely up to you. All right, last example in 11.1, we have angle measures. It's important to note those are what kind of angles? Are they interior or exterior? They are exterior. So I'm going to add those angles up. So I have 2x, a 32, a 40, an 85, a 48, and a 52. All right, because those are exterior angles, what have we learned today about exterior angles? They're going to add up to 360 degrees. Again, it doesn't matter what kind of shape you have. The exterior angles always add up to 360 degrees. So I'm going to combine like terms. There's nothing like the 2x, but I'm going to combine the 32, the 40, the 85, the 48, and the 52, and that adds up to 257. And now I need to move the 257. So we're going to subtract it over to the other side. So 360 divided by 257 is 103. And now we're going to divide each side by 2. If you want, you can leave it as a fraction. You can leave it as 103 over 2. That would be reduced. Some of y'all like decimals better. If you like a decimal better, then you would have 51.5. Either one of those answers, though, would work for me. All right, so if I remember correctly, I think the homework assignment is a worksheet, perhaps. I don't know, it's in RenWeb. You'll have to look there. As soon as you're done with that, send that on in to me, and then tomorrow we will be talking about 11.5, so I will talk to you